Today we'll be discussing the factory object-oriented programming design pattern. We had discussed in the prior posts the proxy design pattern. Factory extends that concept, and in a nutshell, it helps you to dynamically create objects. Similar to proxy, just that the kind of optimizations we are going to do is going to make it much more easier, where you might not even realize you are using the factory to create objects. To begin with, first, we'll start off with the class hierarchy diagram. This one here may look a bit more intimidating than the proxy class diagram we were used to. Though, stay with me, I will walk you through it and this will make much more sense. Additionally, what I've done here is that I have included even the proxy classes as well as the factory related classes in a single diagram to help you compare against the both. Let's dig in. So first, let's look at the wrappers. What are the wrappers here? We had object proxy during the proxy class discussion itself, and we use the object wrapper. In this case here, we'll be using the object registry wrapper. The object registry wrapper are going to have three functions. A get, which is going to return a value of the type of object registry parameterized to type T. A create object, which is going to return an object of class T. And a create, which is a special function which will look up the factory and then internally call create object. Then we are looking at the objects. The objects are object D3 and object D4. The factory friendly objects, they will have a special type def in it called type ID, which will be a type def of type object registry bound object D2, and a constructor. From a user perspective, we have the factory user who will not even realize they're using a factory and would call only object D3 type ID create. If you go back to our proxy discussion, what you'll notice is that for proxy, we had to call the proxy associative array, pass in the string, and then say what object we want to create. This one makes it transparent, or rather opaque to you, and you would just use the object you want to create and just give the standard type ID create to create it. So with that said, let's get to the code. This code is a combination of the proxy code which we had earlier as well as the new factory related code. The reason I've kept it such is that you now have a single file where we can go through and see what the differences are. First is, let's go through the object registry class which we discussed here. The object registry class is, first, what would the factory look like? Factory, just like proxy, is an associative array. The only difference is the key here is now also the type of object proxy. During our proxy discussions, we had the key of the type string. Now we have object proxy. All right. Getting to the object registry, The object registry will be a parameterized class of type T. It will extend object proxy. It will now have a singleton constructor. So first, to declare a singleton, remember we had to create a local qualifier with a static and then the object registry with the type T. And then here we also are doing a get. So the get, what is a get? Get is going to be our publicly visible constructor. Going again to our singleton discussion, this should look the same as a singleton. It just checks if the local handle is null. If it's null, just new it. And this is an additional step on top of the singleton typical constructor, is that we are going to associate this object to the factory by linking the current object with the same current object, so that the next time we were to invoke it without any overriding, we should be able to create these objects. Then we have another function, create object. It will return of the type T, and the only thing it is doing is that it's just saying for this parameterized class type T, I am going to new it and return it. Then we have the static function create. This create is going to create a handle of type T. Then it is going to look up the factory, and this is a very important fact. It's going to look up the factory and then call, after looking up, the create object on the value returned from this lookup. Once the object is created, it will clone it, and rather that cloning is done, we are going to cast it to the current object handle, which is th casted. We'll check for any errors in the inheritance chain, and then we'll return the newly created object. This is the key object registry which we define. Now we go through our object hierarchy. These are the objects we would like to use in our environment. So think about UVM sequence item. You extend it. You create my packet class. Then you create my short packet class. They are equivalent to the kind of objects we want to use in our systems. So object D3 extends object D2. Object D2 was something which we used during a proxy discussion. Then if we were not to use this type def, we can still go through the whole discussion. Type def is only helping us simplify certain elements here, and what they are, we'll get to it. So we just have constructors for both. Then let's get to what the code looks like. Here we'll have and we can just directly look at the output here and see what happens. So we see the displays of in factory example. We are here. Then it does, now we are using without a type ID. How would we go about setting the values? What we would do is, first we would create an object registry wrapper. It's object registry class is just a wrapper around the actual class. It is similar to having a lightweight stand-in for the actual object, which are obj d1, d2, d3, d4. So object registry wrapper with the type class of d1, we do a get on it. So get is going to return us a value in the form of object registry obj d1, and then we are saying that we want to set the value in the factory to this, to obj d1. When we do this, it is now associated. So in the factory, the next time we were to call hey factory, for this particular class, can you create an object for me? It will create the object, and when we do a print here, it will print out that it is in objd1.print, which you see here. Then we go to objd3, and here we are going to use the special type def we have, the type ID. So you see how verbose this code became? Type ID simplifies it. Type ID, if we now look at what the usage is first and then go back and see what type ID is that we say for an objd3, I would like to create an object. But instead of just doing objd3 is equal to o3 or o3 is equal to new, we are going to use the factory to create the object for us. Factory is going to help us check for any dynamic overloading which has happened or any overrides which have happened anywhere else in the system and getting us the latest and greatest class which has been declared. So objd3 type id create is going to get us the object objd3. We can check it now. You can see that now it's being printed out. I'm newing objd3 and that's for this one. What is the equivalent in UVM for this? It would be, let's say, my scoreboard, SCB, and SCB, you new it via factory. And you call my scoreboard type ID create scoreboard this. The SCB is just to give the name for that object, which is going to show up in your object hierarchy tree. And this pointer is passed in to give the context of where you are going to create this. We also have setInst override, which means that we would like to know the specific context where we are creating it so that we can check for the correct set of overrides. Not all of the overrides are global by nature. Alright, now that we've seen this, let's look at the type ID and what it says. Type ID is nothing but the object registry objd4. And to make it simple, we also declare it within the class itself. So anytime you are declaring a class, you just quickly write out this type def there. This type def implicitly shows up whenever you use UVM object utils or UVM component utils. And so most people are unaware of it. Now that we've done this, let's look at how you would create for objd4. Same thing, you would just do objd4 type id create. Then we are now going to do a factory override. Factory, we are going to pass in the objd3 type id get, and then we are going to override it with d4. If we go back to our class chart here, we see that objd4 extends objd3. So when we are overriding this, and the next time we are creating it, we should see that it is newing objd4. The additional thing you will see here is that as a virtual function, whenever you're doing new, it will always call the super. So with that, that's the factory example. Thank you so much for your time.